so 3 key points. What are we going to choose? -1, 0, and 1, because our exponent was just x, right? Okay. If I put -1 into the function e to the x, what do we get out? What do we get? 1 over e, right? 1 over e to the first, or e to the -1 power, which is approximately 0.37. Okay, so that's going to be right about there. If I put 0 into that function, what do I get? 1. Yep. That one's right there. If I put 1 into that function, I get
2.7182.
e to the first, which is what? 2.71.
Yeah.
1, 2. There we go. Okay, so that function goes like that. Talk to me. Domain or range? Domain. Oh, it did. Whoa! See, here we go. Craziness. Didn't like how I drew it the first time. Okay. Domain, right? All real numbers. Range. Y is greater than 0. End behavior. As x goes to positive infinity. Positive infinity also, because it's going up. As x goes to negative infinity, 0 from above. 0 plus. Okay, I like it. Everybody good with that? Okay. What about the second one? It's going to be a decay because the exponent's negative, and we're talking with e's. We learned that last week. Okay. What else from our transformations yesterday? Anything else? A reflection, maybe? Which way? Horizontally. Cool. Okay. All right. Let's try it. 3 key points. -1, 0, and 1. Except this time now this one becomes e to the first, which is approximately 2.71. This one becomes 1, and this becomes e to the negative first, which is approximately 0.37. 1, 2, 3, 1.37. So it really was a reflection in which axes, x or y? In the y-axis, yep. Domain, did it change?
No.
Nope, so it's still all real numbers. Range, did it change? Nope, so it's still y is greater than 0. End behavior, did that change? Yeah, so now as x is going to the right, where's our function going? 0 from above. Okay. And as x is going to the left, it's going to positive infinity. Good? Now, a couple of thinking type questions for you. First one I think you can handle. Okay? What can I put in for x if I got a base of 5 and you give me 25? Yeah. 2? And we all agree with 2 there.
Yeah.
Because 5 squared is 25, right? Okay. I would agree with x here would have to equal 2. What about 4? I would put in 127 in for x. Negative 1/3. Check it for me. Try your 127.
Okay.
Use your calculator. Yep. Try your 127. Try your negative third. 1/9, by the way, in a decimal form is 0.11111111111111. Repeat. Did your 1/27 work? No. Did your 1/3 work? -6? No. It's something negative. Why is it negative?
Because it has to be a fraction.
Because it's got to be a fraction, right? So we want to make this 3, we want to bring that to the bottom, right? So -2. So x here would be -2, because then this would be bring it down to the bottom and make it 3 squared, not x squared, 3 squared, and then that would give me 1/9, right? Okay. What about number 5? It's +3 or -3? If I put in +3, what do I get?
You get 0.88.
I get 1/8 though, but I want 8.
Yeah, that's negative.
So that makes it -3. Okay? Now, I ask you those 3 questions because I want to answer to this question. 2 to the x power equals 10. Shoulder partner, try and figure out the answer to that question. Okay? 2 to the x. Give me some possible, well, so first off, let me ask the question. Can we get x exactly like we did back here? Oops, missed the spot. There it is. Like we did back here on these 3. Can we get x exact? No? Okay. That's good that you didn't say that at 5. Okay. I've had that before as an answer of 5 there. Okay. What do we come up with then for an estimation?
3.3.
I'm going to stop you right there, okay? Because 3.32 is good, okay? But so if we went 3.3 on your calculators, well, first off, how did you know, Ben, that it was 3.3 something or 3 point something? Let's say.
I just guessed and checked.
Guessed and checked it, okay?
You put the x power of 3, it would equal 8, so you know it has to be a little bit larger than 3 for that power.
How do you know it's not 4?
Because if you put 4 in there, it would be 16.
It'd be 16. So it's got so 10 is between 8 and 16. And it's closer to 8 than it is to 16. Okay. All right. So if you put 3.3 in there, what do we get?
10.0056.
Put 3.3 in?
Wait.
I got 9.84.
I say it's got to be, it's like 9.85, right? Okay. If you go out another, I heard you guys back there, you guys were talking, you guys went 3.33, and then you went 3.333, right? Okay. And kept going. Okay. I tried 3 1/3. Okay, because that's 3.3 repeating then. And I got 2 to the 10/3 power, because that's 3 1/3. And I got 10.079. But neither one of those works out, right? Because I want it to be exactly 10. All right? So, that's our dilemma today. Okay? If we think back to last week, we had this dilemma already. We were talking about the city of Fitchburg in Pennsylvania and them doubling their population if their growth rate was 2.9%. Okay? And so we came up with, you guys probably don't remember it, but we came up with that equation. And we wanted to double that. Well, that's the same thinking as what this 2 to the x equals 10 was. Okay? Last week, we solved it by guessing and checking. Actually, I think last week, didn't we put it on the calculators? We put it on the graphing calculators and we got the intersection. Okay? We could have also done it how you guys just did it with guessing and checking. today we're going to try a third method, and that's called using the inverses. Okay? Now, inverses are opposites, right? Adding is the inverse of subtracting. Multiplying is the inverse of dividing. Squaring is the inverse of square rooting. Yep. Okay? Alright? We got to try and find a function that we can invert on this 2 to the x and use that then to solve it for x. Now, the basic behind it is you are going to switch your x and your y. Okay? So what I'd like you and your shoulder partner to do in a couple of seconds is I'd like you to graph, preferably in 2 colors, because then you can kind of see which one's which. So if you had a pen and a pencil, or some of you have a highlighter and a pencil, or super bright colored pencils. See, I told you were going to use those. Okay? Alright? So do 1 color for one side. So this is our function right here on the left. That's our function. Graph it. And then answer all these questions: domain, range, asymptotes, x-intercept, y-intercept, increasing, decreasing, end behavior, and so forth. Then go to the other side of the paper where that's your inverse. If you'll notice here, this point that you would graph would be -1, 1/2. If I plug in -1 into that function, I get out 1/2. Well, over here on the inverse, actually let's go over here on the inverse, that point becomes 1/2, -1. We took the x and the y and we flip-flopped them. We switched them. Okay? So do the left side in 1 color, do the right side in another color, and then we'll talk about it. Ready? Steady? Go. Pick me a color for my original function. Hank, we gotta see it though. On green. Orange? Okay, we'll go. This is my orange, just so you know, right here. Okay? 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 So, based off of, I'm going to borrow your old one. Okay? So, based off of this one, I go through the point -1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8, and so on and so forth. Correct? So that is this function right there, correct? Yes? Okay. Like it? Domain. All real numbers. Range. Y is greater than 0. Asymptote. Y is equal to 0. Let's put it right on there then right away too, just so we can seed it. Okay. Y-intercept. 0, 1. X-intercept. None. Increasing, decreasing. It's increasing because it's getting bigger as we're going to the right. End behavior. As x goes right, going to positive infinity. As x goes left, 0 from above. Fantastic. Everybody good with that? Yeah? Okay. Now, remember what I said at the beginning of this problem. What are we doing?
Using the inverse.
We're inverting this one, right? So what do we do when we invert? Not reflect it. We switch the x and the y, right? Okay. So, color, did somebody say green for the inverse? Okay. All right. That's good for me. Okay. So the first point was, that I graphed, was -1, 1/2. That becomes 1/2, -1. The next point I graphed on the original function was 0, 1. That becomes 1, 0. Next point was 1, 2. That becomes 2, 1. Next point was 2, 4. That becomes 4, 2. Next one was 3, 8. That becomes 8, 3. So this function becomes that, right? Okay, so now we're looking green and green only. Domain. Okay, range. All real numbers, right? Because it's going all the way down, and it's going, as we're going to the right, it's still creeping up. It's not creeping up very fast, but it's right. Okay? So my range, I would agree with all real numbers. Okay, wait a second. Going back to my orange function, where did I see all real numbers?
Domain. Oh, okay.
Because what happened? What happened?
Negative.
We switched the x and the y, right? What's domain? What's domain? X's, right? Okay, what's the domain of the green, but the domain is the x's, right? Range is the y's. So my domain from my function becomes the range on my inverse. The range on my function becomes the domain. So what's the domain of my inverse? X is greater than 0. Okay? My orange asymptote was y equals 0. What's my green asymptote? X equals 0. My y-intercept was 0, 1. Becomes none over here. And my x-intercept becomes 1, 0. You peng, increasing or decreasing? It's still increasing though. Because as we're going to the right, it's still getting bigger. End behavior. As x goes to positive infinity, it's going to positive infinity. Now that one's kind of hard to see, but those two actually did get switched. Okay? You can see it better on the going the other way. As x over here in orange, as x went to negative infinity, my function went to 0 from above. Well, now I'm not going to negative infinity. I'm going to 0 from the right. And my function is going to negative infinity. Okay? These two right here got flip-flopped. Okay? It was harder to see up here, but these two also did get flip-flopped. They just happen to both be positive infinity. Okay? What you just did, well, actually tap the brakes. I got a little ahead of myself. I got so jazzed up. Okay? Is the inverse, so is the green one a function, is the question. Oh, I got to scroll back down. Is the green one a function? Yay or nay? Yes or no? How do we play America's favorite board game, function, not a function? We use the what? It's even more than a straight line test. We use the vertical line test. So if I took here, let me get a vertical line. Okay? So if I use a vertical line and I slide it across the graph, it should only touch in one spot. And it does. It only touches in one spot. So is that a function? Yes, my inverse is a function. What do you notice about the domain and the range from the function to the inverse? They switched too, right? Oops, I don't like that. So, what did you notice about the asymptotes? They switched too. Booyah. Okay. What you guys just came up with was something called a logarithmic function. Okay? A logarithmic function does this. It finds exponents. You want to make note of that right there at the top of page number 3. Logarithmic functions are exponent finders. Yeah, buddy. Okay. So, what we're looking for is the exponent that we could put on 2 that equals x. Okay? And we use that, or we solve that using logs, using logarithms. Okay? Now, this right here, as an FYI, this is, or this gets read in a specific way. Okay? It's not log 2x. Okay? It's log base 2 of x. Okay? Log base 2 of x is how you read that. Okay? Or a little bit later on, we could write it down here. This would be, this one right here is log base 2 of 10. Okay? Which is how we would use to solve that 2 to the x problem equals 10. Okay? Now, some calculators, the most popular calculator in school, this TI-30X2S1, okay, this one, doesn't have log base 2 on it. Okay? We'll learn in chapter 11 how you can solve log base 2 problems. Okay? It's something called the change of base formula. Okay? So these only have log base 10 and log base e on them. Okay? Some of your more modern type calculators have it on them. Okay? Like the Inspires. The Inspires have where you can go into the log portion and you can type in the base 2 and the other part 10. Okay? And so then when you hit that, but some of yours will go right to the answer, some will just keep it in exact form. Log base 2 of 10 is the exact form. The rounded form, I couldn't think of the word rounded there for a second. The rounded form is 3.32193. Okay? And we will get that next chapter. We just wanted to give you a little taste of it, dip the toes in it before we get to it next chapter. Okay? So the answer to today's question is 3.32193, which you were getting expertly close to.